I'm a serial entrepreneur also. I'm a professor at Rutgers, but I'm also a fire starter. So, you know, my past has been building cement companies and learning how to make cement cheaper than all the big cement companies can. So now I'm putting my skills towards creating advanced composite materials that are also inexpensive. So along those lines, there's an example of some of the first materials that we've made that have wood-like performance. Now, I'm an alumnus of MIT from course 3, Material Science and Engineering. So let's hear a little bit about ACMs. This button? All right. Okay, so what are the advantages of these new materials, which, by the way, can cost literally 10 cents a kilogram, 50 cents a kilogram, depending on what kind of material you want, which are, by the way, carbon negative, which means that the process itself extracts more CO2 from the atmosphere than it's generated. So it's a low energy process. Novel microstructure, patented. When we make the material, typically when you work with ceramics, you get shrinkage. With plastics, you typically don't. So you get some of the advantages of plastics, which is net size, net shape forming. These materials are crack resistant, tough, strong, creep proof. If you want, take one of these samples and throw it down on the floor against the wall, be my guest. Just bring it back to me, because the last meeting I didn't actually get my samples back. They're flame retardant, so imagine framing a building without having to worry about the place coming down on you, because it doesn't burn. We've made very large shapes with this kind of technology. So you can't usually do that with ceramics. You certainly can with plastics, but this stuff's cheaper than plastic. So this is a basic process. I don't have time to really tell you how it really works, but it's an aqueous process that operates at a very low temperature, where the ceramic actually forms a bond first before we actually create bonds with the plastic. And there's lots of different applications we can talk about, but let's talk about replacing wood. Some people see wood as a carbon negative material. I see it as a material that if we were to replace, it would actually have bigger impact on greenhouse gas emissions than cement and concrete. That's coming from somebody that has a cement and concrete company that's supposed to reduce CO2 emissions. So I'm telling you that you know, thinking about methane, as we heard earlier, is very important. And so we also can avoid deforestation and making it for various markets, such as shipping pallets, for example, can make a huge impact on the amount of shipping pallet waste created each year, as well as having successful shipments, because these pallets do fail quite a bit in application. So there's many performance ideas, for example, for that application, where long service life can actually create a new rental market. The gentleness of the process allows you to put tracking devices into the actual shipping pallet, and then being able to avoid both CO2 and the methane emissions really make a huge impact. Just some examples of some of the materials, like with high density polyethylene. You can see that across the board that these composites, depending on their composition, can be extremely inexpensive. And so, for example, these two systems, which are really attractive, not only serve to replace materials like wood, but, for example, having a fiberglass boat, which is actually not very cheap. These materials can actually replace fiberglass because they have stiffnesses greater than glass-reinforced resins. Some really interesting things. Aside from that, we can work with a variety of different polymers. So people who are making polymers that are trying to think of ways of reducing their carbon footprint in common plastic products, these have great potential. They also do things that plastics can't do. For example, you take a plastic and heat it, it softens and it loses its shape. These materials at most increase the thermal expansion coefficient, but you'll notice that their thermal expansion coefficient's light to begin with, low to begin with. So looking for partners. We're looking for upstream polymer manufacturers, downstream technology licensees. There's a future here for replacing paper, cardboard. You know, those things are 50% of landfill these days. That's why you see those little white tubes coming out of the ground, emitting methane. Automotive parts, let's start with interiors, defense and aerospace. You know, just a lot of different things that are made of metal and plastic could be made of these. Pharmaceuticals, marine structures and vessels, a lot of different opportunities for low-cost materials that replace high-cost, high-carbon footprint, positive carbon footprint materials. Thank you.
Thank you, Rick, and thank you so much to all the startups and to all of you. And now I'd like to invite you to join the lunch exhibit, where you'll be able to engage further with the startups, enjoy a nice lunch, and let's meet back here at 1:15, please. Thank you so much.